Hello, assalamu alaikum. In last class, we have discussed static routing. Static routing means you have to define all the destination routes and manually. Administrator maintain this route statically. So that's why it's called the static routing. If your network is a medium or large, number of device increases in your network, so in that case, static routing maintain is very complex for an administrator. So in that case, we should use or we should go with dynamic routing. In dynamic routing, there are three benefits. Like lower administrative overhead, automatically destination will be raised from one network to another network, and another one is increased network availability and greater network scalability. Increased network availability means when you get a different path to get the different destination or same destination. If one path has down, automatically failover path will be the primary path. So in that case, manual intervention not needed. So in that case, we say dynamic routing have increased network availability, and greater network scalability means just you can put another router or new router in your existing network. It's very easily, and dynamically non routes dynamically set the best path. This is the benefit of this dynamic routing. There is a sample topology of dynamic routing. 3 AS is connected, interconnected with each other. One S is connected through ABGP. ABGP. In these levels, we not show or we are not showing BGP related concept and configuration. But if you just for short brief, this the three organization. This is the one organization, and three organization is connected with each other. If one organization or one is connect with another AS, the intermediate routing protocol must be BGP. BGP have two types. So one is eBGP, external border gateway protocol, and another is IBGP, internal border gateway protocol. If one is connect with another is, we should configure eBGP. If in a AS, if different router communicate with BGP, then we configure IBGP. So and this is the topological division of regarding BGP. If we see the internet is just multiple is connected with each other, or you can say multiple organization connected with each other. This is the same concept or same view showing just here showing only three autonomous body or autonomous system is connected with each other. If we consider in a organization we configure ICP, interior gateway protocol. For interior gateway protocol, we can configure static routing. We can configure ICP like OSPF, ISIS, 3, any protocol you can configure as ICP, interior gateway protocol. So today we discuss OSPF as a integrated protocol, open shortest path fast. It's a dynamic routing protocol. It's a IGP. It's a link state routing protocol. So OSPF have some benefits. If you consider the distance factor, if you consider with distance factor routing protocol like RIP is periodically send the database update to their neighbors or with its neighbors. But in OSPF, if something changes, if network changes or just voice web trigger that update only. This is the very basic difference between voice wave and distance factor routing protocol. So just see the topology. Different router is connected with us with this other. Here showing three areas. This the area 0, and area notation we can use decimal 0, or we can use IPv4 format 0.0.0.0. Both will be eligible. uh, Backbone area 0 is also called the backbone area. Backbone area is connected with different non-backbone area or different other area. Area 1 and another area is area 2. This topology is called the multi-area voice web topology. When a different area exist in a single network, we call this the multi-area OSPF. And OSPF use the shortest path algorithm. Dijkstra algorithm. Basically, in backend, OSPF use Dijkstra algorithm to calculate the shortest path. If one destination have multiple path, shortest path will be coming in forwarding table, and your communication will be happened through that path. If primary path goes down, OSPF dynamically recalculate the backend algorithm and select the best path, and that path goes to forwarding table. But in routing table, both paths are available same time. So this is sample topology for configuration testing. Three different router is connected with each other, and all router have in OSPF area 0. And this the configuration of OSPF here showing only for IPv4. If we only OSPF, if we set the only OSPF, this is for IPv4. If we set OSPF 3 is for IPv6. So today in our lab, we will show both OSPF version 2 and OSPF version 3, means IPv4 and IPv6. I will show you how to configure OSPF for IPv4, how to configure for IPv6 also. So go to our lab and test OSPF configuration. Okay. So this is today this is our topology. Three different router is connected with each other, and the router have multiple network is connected, multiple LAN. Uh, so check the configuration. All router in OSPF 0, and their IPv4 and IPv6 address exist, and three routers. So first one we go the BMX1. Check the configuration first. Show mass display set. And there is we see multiple static routing is configured here. So get 0 by 0 by 0. This is the IP address of router 1 and router 2, 12.12.12.0/30. We use 12.1, and IPv6 address is 2023 a colon 11 colon double colon 0. That means double colon 1. IPv6 address is configured also, and go to gig 0 by 0 by 1. One is network is 192.168.10.1/24, 2023 a colon 1 a double colon 1. is the one LAN is connected with PC1. In JNCIA exam, is mandatory to learn WSPF single area and multi-area configuration. Only single area concept is enough for JNCIA. Okay. And gig 0 by 0 by 2, this is the another LAN which is connected. PC2 LAN is 10.0/24 and 2023.1D:1 is the IPv6 address, and this is your loopback address. So here static routing has configured. We remove the static routing and replace with OSPF routing protocol. Okay, so static routing we removed here, delete and delete, then default route. Okay, then commit. Run show route. Show route. This command will show both routing table. For IPv4, routing table is inet.0. IPv4 route is in this table. Uh, there is no dynamic routing protocol or static routing protocol in BMX1. So all route in direct and local. And for IPv6, we see the same. Direct and local route is available in routing table. No dynamic routing is available because no dynamic routing has configured yet here. So go to BMX2, show this plus side. This is the interface of the 0 by 0 by 0 IPv4 and IPv6 address configured done. Z 0 by 0 by 1 11.1 B:1 configuration, IP configuration 21.1, IP configuration done. Z 0 by 0 by 3 23.1, IPv4 and IPv6, and last one is loopback also configured. Here we configured the static routing. So static routing, we remove the static routing, delete static route, this, delete the static route. Static route destination must be plus 10, 20, 12, 22. Comment BMX3 show this person. Okay. So static route, static routing removed from this BMX2, and then go to BMX3. BMX3 also IP address is configured 23.2 IPv4 and v6, Z 0 by 0 by 1, 12.1/24 C:1. It's okay. Z 0 by 0 by 2 is also configuration done, and loopback address also done. Static routing, we remove static routing from here. No need, delete the default route. I can get it, then commit. So I have a plan. 3 router is connected with this other. 3 router will be in OSPF area 0. Okay, so let's Start the configuration. Before going to configuration, check the PC IP configuration is okay or not. So IP interface break is administratively down. Go to another PC. Down. Enable. Administratively down. Enable. PC4. Down. Last one is PC5. Last one is, sorry, BMS3, PC5. 1, 2, 1, 2, 3, 4, 5, then 6. Enable. So I think, okay. So let's add this configuration first. Interface is 0 by 0. Shut down. Interface. Interface. On. This one. This one. This 6. Okay. So this is the basic one. So running config interface is 0 by 0. IPv4 and IPv6 address has configured. Check the configuration in others PC. Okay, B4 and B6 done. Okay, and we go. This is 6. Okay. So if we send ping from PC1 to PC2, PC1 to PC2, that will work because both PC is connected in same router. If we send ping PC3, that will not work because this need routing protocol to intercommunicate unreachable. So we configure the static routing, sorry, dynamic routing protocol is OSPF. Okay. In BMX1, there is 4 interfaces. One is loopback, one is router to router interface, and 2 LAN. One LAN is PC1, another LAN is PC2. So 4 network is connected in BMX1. That means these the 4 interfaces. And the interface is the 0 by 0 by 1, 0 by 0 by 2, 0 by 0 by 0, and loopback. So go to the configuration. edit protocol OSPF. So here is two options. One is OSPF for IPv4, and another one is OSPF3 for IPv6. First, we configure the IP version 4, then set area 0, interface. First one is loopback, LO0. Loopback interface, it's like LAN. We can send any WSPF related message through loopback. We can send just a WSPF message from this interface to this interface. So router to router interface will learn WSPF related message. Others interface like loopback, LAN interface, no need to send WSPF related message because there is no neighbor within LAN interface or loopback interface. So if we configure OSPF in loopback 0 or LAN interface, we can set this interface is included in OSPF, but this interface work as a passive. No need to send OSPF related message. Passive means no need to send OSPF related message because this interface have no OSPF neighbor. If any interface have OSPF neighbor, you not set passive keyword, but no OSPF neighbor, we should set passive. Okay, the number one, then interface PC1 is connected Z0 by 0 by 1 and PC2 G0 by 0 by 2, G dash 0 by 0 by 1. This also passive, and another interface to this also passive, and Z0 by 0 by 0, this is the interface, and OSPF message must be sent through this interface from PMX1 to PMX2. So if we say check the Wireshark in Z0 by 0 by 0, we can see the OSPF message is communicate through PMX1 and PMX2. So just for visualization, we set the we just enable the Wireshark. So then go to interface configuration, then interface. When configure interface Z0 by 0, this interface is connected. This interface is directly connected one router port to another router port. So in that case, we should configure this interface type is P2P, point to point. If one switch is available there, if one switch is connected inter between these two routers, this network is called broadcast or LAN network. So in that case, no need to set the point-to-point keyword after the interface. If router is directly connected with another router, between router, there is no layer 2 device. So in that case, we say we configure the interface is P2P, point to point. So that's all for BMX1. For WSPF IPv4, then commit. Set the commit command. WSPF has done this. That's it. This is the WSPF configuration. Then back to default configuration. See the WSPF message. So OSPF sent 12.1 through multicast IP. OSPF use this multicast IP to send the hello packet to neighbor. So what is the details of OSPF? Open shortest path is the header option. We use here version 2, that means OSPF version 2. OSPF router ID is 1.1.1. Here is loopback is 1.1.1. That's why router ID will select 1.1.1.1. Also, we can set the router ID manually. Set routing options, router ID, and router ID will be 1.1.1.1. If you set the manually router ID, this router ID will act for all routing protocol. If you configure BGP router ID, also this one. Okay. Then WebSpam hello packet. In hello packet, they send the hello interface, router priority, data interface, designated router, and backup designated router. Designated router and backup designated router here 0 because we set the interface P2P. In that for that case, no designated router and backup designated router will be elect. OSPF LLS data backup. So we enable the interface in OSPF. OSPF will try to communicate with neighbor. Try to communicate with neighbor. Okay, then go to VMX2 and set the similar configuration. This is the gig 0 by 0 by 1, 2, 0 by 0 by 0, loop back, and 0 by 0 by 3. So this is the identical configuration. We can copy this configuration 0, 1, 0, 2, and 0, 0, 0. So then go to VMX2, then paste this configuration, and one extra is Z0 by 0 by 3 is the extra 0 by 0 by 3. This also in interface type P2P. So if we show mass OSPF, then display set this router configuration is this. Just simple, done. If you go to VMX3, VMX3 have 000 LAN 1, 2, and loopback. 1, 2, and loopback. So this is the very identical of VMX1. So go to VMX3, then copy this configuration, go to VMX3, and then paste. Interface type P2P. So committed the configuration. Check the configuration. It's okay. Then check the WSPF neighbor. Run show WSPF neighbor. Yes, WSPF neighbor in full state. Your WSPF is working or functional. Two neighbor in VMX2. VMX1 is one neighbor and VMX3 is another neighbor. And if you go to VMX3, there are also one neighbor, and neighbor is 2.2.2. So if you set the router ID in this router also, set 2.2.2.2. Router ID is 3.3.3.3. Manually set router ID will more effective than dynamically set. Okay. So here OSPF neighborship is full and up. Then check the OSPF routes. OSPF route is available in your router now. Run show route. And this loopback, I'm checking the VMX1. Router to loopback, router 3 loopback, router to LAN, router 3 LAN, and router 2 and 3 inter between network, all are in a remote network for VMX1, all route will be coming through OSPF routing protocol. So check this one. All routing protocol, all route is available here. 2.2.2 is this route is coming from VMX2, and this is the OSPF route. For OSPF route, the preference is 10. The preference is 10, and the next stop is 12.2 for IPv4. So two routers, a loopback 2.2.2 and 3.3, both are coming in this router route table through OSPF routing protocol. Okay, and another one is full LAN 11.0, 21, 12.0, and 22. 11.0 is coming through OSPF, 12.0 coming through OSPF, and another one is 21 and 22 also coming from OSPF. Default this router interface metric, set the interface metric is 1. Every interface metric is 1. So if we see 21, this network is connected directly connected with VMX2. When getting this route in VMX1, the metric value is 2. Metric value is 2. This interface metric value 1, and this interface metric value 1. So 1 plus 1 we get 2. If we check the 22.0, 22.0 which is connected with BMX3, so 1 plus 1 plus 1, so 3. We see here metric 3. So default every interface metric value set in 1. So in that case, this is the metric value of these two routes. Using this metric value, OSPF calculate the shortest path basically. Okay, then check the reachability from BMX one LAN PC to another router PC LAN. So if you send packet enable, show running config interface Z0 by 0 is the PC3. Cisco. Now this is missing. Okay, so send packet from PC1 to PC6. PC6 IP is 22.10. Send packet. Yes, packet is sent, no problem. If you send the trace route command to 10, and we'll also get ICMP. This one will send now 10.10 to 22.10. Okay. Is there any consideration take when you must form an OSPF agency between different vendors, for example, Juniper, Cisco? When configure OSPF for different vendor, consider OSPF basic adjacency rules. We have to consider OSPF basic adjacency rule like point-to-point network in same subnet, and area setting will be in same subnet. Your interface MTU will be same in both end. and router ID selection or router ID setting will be unique for every router. This is the WSP basic consideration before the configuration. So this is also applicable when you consider multi-vendor network, like Cisco router is connected with Juniper, or Juniper router is connected with another any vendor like Huawei, like MikroTik. Just consider the basic concept of OSPF. That will be okay for in every place. Okay. Okay. So if you go to go to the PC1, this is the gateway, then point to point is router 1 and router 2, then another point to point is router 2 and router 3, then go to PC6. This is the path. Traffic will send this path. Okay. So our WSPF for IPv4 testing done, and now test the IPv6. WSPF for IPv6. So edit protocol. WSPF 3. So nothing is here. Set area 0, interface hello 0. That should be in passive mode. Interface Z ZE dash mm, 1. That should be in passive mode. Interface 2. That should be in passive mode. And interface 0. That should be in interface type P2P. Like IPv4, it's identical. Spec for IPv6 configuration done. Very simple. For the configuration, you can check loopback 1, 2, and Z0 by 0. BMX3 have same interface connected. So we can copy this configuration and paste to BMX3. Done. And in BMX2, Z0 by 0 LAN and loopback. BMX2, we can also copy this configuration, add another interface which is connected 3 with BMX3. 3 interface type out. Now check the OSPF3 run show OSPF3 neighbor. Okay, OSPF3 neighbor. This neighbor is for IPv6. For IPv6 WSPF neighbor, we see here a link local IP between BMX1 and BMX2, and state is full. Means your WSPF is functional or up. Okay, BMX3 have two neighbors. So one is BMX1 and another is BMX3. And if you check the BMX3, WSPF also up. Okay, so check the route table of BMX1, run show OSP, sorry, run show route in BMX 1, that means 106.0. This remote loopback is 2023 a double colon 2 A double colon 3, A double colon 2, and A double colon 3, both loopback IP is coming through OSPF 3, and the default preference, OSPF default preference is 10, and BMX2 and BMX3 connected LAN like B, C, E, F, B, C, E, F, that means B, C, okay. This also coming through OSPF, and EF also coming through OSPF. So if you consider this destination route, E means is connected with BMX2. In BMX2, this is the destination. This route is coming through OSPF 3 routing protocol, and preference is 10. Metric value is 2 because this per interface metric value is 1. Metric value 1 and another is 1. That means 1 plus 1, 2. And if you see if you see this route 1, 1, and 1, total metric value is 3, and your neighbor IP will be in multicast IP. Multicast IP will make from this interface with the using of EUA64 method. Okay, so we are getting the destination route through OSPF. Now check the OSPF reachability, then send packet from PC1 to PC6. This is the IPv6 packet, and getting this one. Okay, test route. How to close this packet? Gateway A double colon 1, then BMX to BMX1 to BMX2, A11 double colon 2, 11 double colon 2, BMX2, then BMX to BMX3, double colon 6, double colon 6, then PC6. OSPF database, yes. Okay, OSPF database. If you check the OSPF database, run for IPv4, run show OSPF database. That means run show OSPF, then you set the help. You'll see multiple command. Database. If you see database in OSPF, database, all router in OSPF area 0. I am in this router, and this router is the our neighbor router. All are in area 0. Okay. OSPF database, and you can go details. OSPF database, different type of database is here, or you can say different LS type is exist in OSPF. So you can check through database different type of LSA like router LSA, network LSA. If you said network LSA is not here, net summary, that means summary LSA not here, because all router in a single area, all router we configured in single area. Yes, okay. If you consider multi-area, this is a single area WSPF configuration. If you consider here multi-area WSPF, so just you consider this router, that is BMX2 in backbone area. This interface is connected in backbone area. This interface is connected in backbone area. If you consider this one and this also in backbone area. So if you just redefine if you just redefine this are in area 0, this are in area 0, and this two interface, this LAN interface and loopback interface is another area, might be area 1, and this router connected interface except the point-to-point interface is connected in different area. This is called the multi-area Wi-Fi configuration. If you test this one, just reconfigure the BMX1 and BMX3. In BMX1, if you consider edit protocol OSPF IPv4, for IPv4 setting, this all interface in area 0, all interface in area 0. If you copy this one or copy area 0 to area like area 1. So here in area 0, all interface is here. So um, remove except z 0 by 0 by 0. That means delete, or you can set here show display command and remove this one. This interface will be in different area. Consider 1, 2, and loopback 0, LO 0. So okay, so only z 0 by 0 by 0, this interface in loopback in backbone area. Another interface like PC1, PC2, or you can set loopback interface in area 0, no issue. Area 0 interface LO 0 passive, and show displacement and remove from area 1, remove from area 1, delete, show. So this is the multi-area configuration. Area 0 have two interface, directly connected interface to another router, Z 0 by 0 by 0 and loopback. And there are two LAN interface, PC1 and PC2 is connected another area. Okay, just define the another area and include this interface in different area. So we also remove from this interface area, delete. So area 1, this two line interface Z 0 by 0 by 1 and 2, and in area 0 router loopback and router to router interface is in area 0. So this is called multi-area configuration. Just set the commit command and go to BMX3 edit protocol WSPF. You consider here another area. The area is area number 2. So set show displacement. So you go back and see 0 by 0 by 0 is in area 0. Other interface will be different area. So remove this one, delete, remove this one, and this interface will be in area 2. This interface will be in area 2. So set the area ID, that is 2. Then another interface is 2. This is the configuration of multi-area, WSPF multi-area configuration. Sure, then display set. It's easy, very easy configuration if you consider multi-area. Okay, so this interface, this BMX2 already configured in backbone area, that means area 0. So if you just checking the neighborship, run show WSPF neighbor. So WSPF neighbor is up. So check the BMX2 to neighbor is up, and check the BMX3. Okay, if you check now route table, run show route inet 0 and inet dot 0, that means this loopback bmx2 2.2 bmx3 bit 3.3.3 we are getting through WSPF area 0 and pc3 pc4 pc5 and pc6, that means 12.0 12.0 and 22.0 metric next stop, everything is same. But if you see the WSPF database, you can see the difference. Now show WSPF database. In database, you see sometimes before we see only area 0 in database, this route exists only. Okay, this route exists only. So this route is router LSA and this route is summary LSA. Because this summary LSA means this coming from different area. This coming from 10, 12, 20, 22. This route is coming from different area. One is coming from area 0, another is coming from area 2. This is the, and for area 1, that means this router is in BMX1, area 1, this is the another database. So if you see the LSA type like network LSA, no network LSA exists, router LSA, yes, router LSA exists. If you net summary or summary LSA, you get this one. Okay, this is summary LSA. That is coming from different router. Okay, so I show the multi-area configuration for WSPF version 4. For home task, you just configure WSPF version 3 as a multi-area. Okay, any question regarding WSPF? WSPF version 3, it is clear. Okay. So in OSPF, there are multiple message communication will be happened here. Hello message is continuous to check the or maintain the neighbor. Second one is LSDB link state database. Just stop. DB description. This is the second message. Third one is link state update. Then is link state request. Then is link state acknowledgement. Every type of message will communicate when you configure the WSPF. Okay, so that's all I think for the chapter. Review question. So our routing fundamental has finished now. So in next class, we'll discuss chapter 2, routing policy. Okay, so today we should close now. If you have any question, you can ask. Okay, Allah Hafiz.